Okay, so yesterday we talked about factoring trinomials, and so you should be pretty comfortable at this point with GCF method. If that doesn't work, checking your difference of two perfect squares, and sorry for the pause, there was just an announcement. And if those two don't work, then you're going to check trinomial method. And today we're going to talk about factoring completely. And so usually when it says that phrase, factor completely, it's like a light bulb should be going off saying, oh, this is the kind that probably I'm going to have to go more than one time. And so once you do your first method, you're going to need to check to see if any of the other methods will also work. So you're still going to check GCF first, just like we've been doing. If there is one, you're going to proceed with that. Then you would check your method 2, then you would check trinomial method. So let's jump in and try example number 1. So right away I'm seeing a GCF of 2. Hopefully you're noticing that as well. And so you are going to pull the 2 out. And that's going to give you 2 times the quantity y squared minus 9. Now normally we would finish there. There was a GCF, we would stop. But now, again, because it said completely, that's usually going to tell us to go one step further. So you are going to look inside of your parentheses and reevaluate and see if you can factor using another method. You shouldn't be able to use GCF anymore at this point because you've already pulled out a GCF. So typically you would check with, start with checking method 2. And so method 2 actually does work. It's a difference, they're perfect squares, there's 2 terms, and so you're going to keep the 2, and you're going to focus in on just this part of the problem, and you're going to factor that as if that was all that was given to you. And so again, we're going to square root both the y squared and the 9 to give us our y and our 3, and there's 1 plus and 1 minus, remember, for method 2. This whole expression is your answer. If you don't include that 2 in your final, you won't get back to the 2y squared minus 18. You would only get back to y squared minus 9. Possibly at this point, these 2 parentheses, one or both, could possibly go even a further step. In this case, we're finished because there's nothing else to factor. So let's take a look at example 2. Again, right away, I'm seeing a 5. So if I pull out a GCF of 5, I'm left with that expression. I'm going to look inside of my parentheses and notice that I can factor that again. There should not be a GCF, and there is not one. I've pulled that out already, but it is a perfect square type on the inside. So that's going to become 5, a minus b, a plus b. And so there's your final. And you should still be checking yourself. If you're going to check, even if it's just mentally, I would multiply these 2 parentheses. If you do it correctly, you would get a squared minus b squared. Then drop down your 5 and realize that yes, indeed, you get back to where we were in the beginning. Okay, so pause the video. You try examples 3 and 4. Come back and push play and see how you did. Good luck. GCF is 3 for this problem. So I'm going to pull out a 3 from every term. And I'm left with this time not a perfect square in the middle, but a trinomial type problem to factor. So I'm going to put my 3 out in front. I'm going to have my 2 parentheses. I need 2 numbers that multiply to 8, that add or subtract to my negative 2. So the numbers I'm going to choose to use for that would be 4 times 2. X times x will give me x squared. Remember, this sign right here tells me different signs. And this sign right here tells me that goes with the big minus plus. And so that would be your final for example 3. Example 4, hopefully you realize that there was a b that was common. And if I pull that out, I would have that expression, which leaves a perfect square type factoring expression on the inside. You keep your b, square root both pieces. One factor is the sum, one factor is the difference. And this would be your final. So again, pause your video, try the remaining examples, and then come back and see how you did. So for example 5, again, I see a common factor of 2. So I'm going to pull out a 2 from all of my terms, and I'm going to get that expression. Then I'm going to look inside and realize that there's no GCFs remaining, which is good. I should have pulled that out already. It's not a difference of 2 perfect squares. It looks like it's going to be a trinomial. So I need to find 2 numbers that multiply to 56 that are going to give me a 1 as either a sum or a difference. So the 2 numbers I'm going to use are 7 times 8. Again, make sure that you bring that 2 down in front. The signs, that sign tells me different. The front sign goes with the bigger of your 2 numbers, so a -8 and a +7. Example 6, GCF of 2. Pull a 2 out from every term. It's not a perfect square problem in the inside. It looks like a trinomial. If I can find 2 numbers that multiply to 20, that add or subtract to 8. My options are 1 and 20. That won't give me an 8. 2 and 10. That will give me an 8 by subtraction. So I'm going to use 2 and 10. Signs are different. The larger one gets your minus. And that's going to be our final answer. Now, example 7 may have stumped some of you. And that's okay because it's different than the ones that I've been showing you. There's no GCF, but that doesn't mean that it can't be factored. You would then see if it's a perfect square type problem. Well, there's a minus, there's 2 terms, and everything's perfect square. So I'm going to go ahead and square root both of these terms. I would get x squared in the front, 1's to give me the 1 in the back, 1 plus, 1 minus. Now you still need to check and see if you can factor either one of these again. This one has a plus in it. I cannot factor perfect square method with a plus between 2 terms, so that one's as far as it will go. So I bring that factor down. This one, though, has a minus. And if I'm just looking at this piece, trying to ignore the one in front, I can factor that again by doing x minus 1, x plus 1. I've already brought down my other factor, and so this becomes your final. And again, it's possible that when you're looking at those 3 or 4 pieces that you have, that you'll be able to go even further. In this situation, we're done, but be checking for those. Sometimes they will go 3 or 4 times. So we'll do some more challenging ones tomorrow in class. Hope you felt successful, and I will see you tomorrow.